All right, Unit 4. This is called Chemical Kinetics. This is a great, great unit. This is probably new for most of you. Probably not something that was covered in much detail in general chemistry. So, chemical kinetics is all about speed. It's all about how fast or how slow a chemical reaction happens. And we do that by measuring the rate of a chemical reaction. So, the rate is just another word for the speed at which a reaction occurs. Okay, now before we even look at how fast a reaction is going to happen, we have to decide, is a reaction even going to happen? So this is all based on the idea of what's called collision theory. And collision theory is just that. We look at, we're going to look at a few different factors about whether a reaction is going to happen or not. So we know that reactions that do happen at different speeds or different rates. Sometimes reactions are really, really slow. When you leave your wheelbarrow outside and the iron starts to rust, it might take a little bit for that to happen, sometimes years. But when you light something on fire, that reaction happens really, really quickly. So when you measure the rate of a reaction, you're measuring basically how fast those reactants you're getting rid of, or how fast or slowly, again, the products are being formed. And we'll talk about that in more detail later on. Okay, so collision theory tells us that a reaction will only happen if there's three things that happen. Now, the nice thing is there's a little bit of review from Unit 3 here. Okay, number one, in order for a reaction to happen, of course, the molecules have to hit each other. They have to collide. If they never ever collide with each other, they cannot react. So that's our first one. And that one's pretty obvious. Of course, for a reaction to happen, for atoms to switch places, for electrons to transfer from one thing to another, the molecules have to hit each other. Okay, the second thing that has to happen is, and we talked about this part in Unit 3, is you have to get over the hill, right? And remember we introduced this idea of activation energy. You have to have enough energy to break the bonds. Again, anytime you break bonds in a chemical reaction, it always requires energy. Okay, and so the activation energy, which is the minimum quantity of energy that the reactants must possess to undergo a chemical reaction, it has to be reached. And if the molecules don't have enough energy to break those bonds, or if there's not enough energy they can absorb, then the activation energy has not been reached, and it will not react. Okay? Now, some of the things that can affect the activation energy are the temperature. Okay? And when I say affect the activation energy, I mean when you increase the temperature, you're not changing the activation energy at all. We talked about this a little bit in Unit 3. When you raise the temperature, you're just giving the molecules more energy, and then more of those molecules have enough energy to overcome this activation energy barrier. Okay? We are going to talk about catalysts. Catalysts are the one thing that changes the activation energy. Okay? Nothing else that we're going to discuss actually changes the activation energy other than catalysts, which we'll get to later on. So again, at this point right here, we're at the top. This molecule does have enough energy to break that bond between in this case, the carbon and the nitrogen. That has to break. And now we're kind of in between the reactants and the products. And now when that new bond forms here between the two carbons, you can see there's a big energy release. This is overall an exothermic reaction. As you can see, the energy of the products is lower than the energy of the reactants, which again results in an exothermic reaction. So they have to collide, the molecules have to collide with each other, and they have to have enough energy to overcome the activation energy barrier. Okay? And now the third one is, and this again kind of nitpicky, but this is the third one, this is the important one, is they have to hit each other, and they have to hit each other in the right way. They have to have the correct orientation. Okay, and that means that if where the reaction happens, if they don't hit each other the right way, then the reaction's not going to happen. Okay, they have to hit the specific part of that molecule in order for that reaction to happen. Okay, look at this reaction here. For the reaction between a chlorine atom and an NOCl atom to form NO and Cl2. So obviously what's happening here is you've got Cl reacting with NOCl to make Cl2 plus NO. Okay, in order for those two chlorines to come together, of course this chlorine has to hit the chlorine atom. If it hits the nitrogen or hits the oxygen, that reaction is not going to happen. That's not the correct orientation for that reaction to happen. Okay, the chlorine must hit the other chlorine atom and for that reaction to happen. So here you can see it. Before the reaction, here comes the chlorine atom. It's going to hit the other chlorine atom. When it does, that is the correct orientation. It now has broken off, and now you're left with just the NO molecule there. Okay, in the second example, notice the chlorine atom is going to hit the nitrogen atom, and when it does, it just hits it, just like, again, a couple of bouncy balls hitting each other, and what happens? They bounce off of each other, and has the reaction happened? No, it has not. Okay, so the molecules must collide, and they must collide with correct orientation. That's kind of 2 in 1 there. They must collide, and they must have the correct orientation, and they must have enough energy to overcome the activation energy barrier. They love asking questions about if a molecule has this or has this, you know, what might be a reason why the reaction might not happen. Okay, so if they do not collide, or collide with energies lower than the activation energy, or collide without the correct orientation, then the reaction will not happen. No reaction will occur. Okay, we call these collisions as unsuccessful because they don't lead to a chemical reaction. And again, what happened after after those collided the wrong way? Nothing. So the reactants remain unchanged. Okay? So when you see problems like these, when you see questions about these, just know there's 3 things that determine. We're only talking right now if the reaction's going to happen or not. We're not talking about what makes the reaction go faster or slower. We're going to talk about that next. Right now, we're only talking, is the reaction going to happen? Yes or no? Yes, if they collide. Yes, if they collide with the correct orientation. And yes, if they have enough energy to overcome the activation energy barrier. Okay, in our next video, as you can see, we're going to talk about factors that affect rate. So once we know the reaction's going to happen, what are some things that can make the reaction go faster or slower? That will be our next video.